The main purpose of today's discussion is to know how to calculate the compressibility factor of dry and moist air. Although there are various methods available for calculation of compressibility factor, however, in this lecture I will use the Peng-Robinson equation for calculation of compressibility factor. So let's start the discussion. So topics of discussion is Peng-Robinson equation, compressibility factor of dry air, compressibility factor of moisture, critical temperature, critical pressure and eccentric factors. So these are the dry air and water component like nitrogen, oxygen, argon, carbon dioxide, hydrogen, helium, neon, krypton, xenon and water, and corresponding critical temperature, critical pressure, eccentric factor are given. So using this chart we can calculate the compressibility factor of dry air and moisture. So first of all, if you want to calculate the critical temperature, critical pressure and eccentric factor of dry air, how we can calculate? So following a step has to be followed. Convert the mole fraction of dry air composition, then multiply mole fraction of each component with critical temperature and add all the critical temperature to give the dry air critical temperature. Similarly, multiply mole fraction of each component with the critical pressure and add up all the critical pressure to give the dry air critical pressure. Multiply mole fraction of each component with eccentric factor and add all the eccentric factor to give the dry air eccentric factor. Like dry air properties, so we have nitrogen, oxygen, argon, carbon dioxide, hydrogen, helium, neon, krypton, xenon. We have percentage by volume data, so just divide by 100. This will give the mole fraction of each component of dry air. We know the critical temperature of each component. Just multiply the mole fraction with the critical temperature, which becomes the critical temperature of that component, and add all the component, it will become the critical temperature of dry air. Similarly, critical pressure we know, just multiply mole fraction to critical pressure, it becomes critical pressure of that component. Similarly do for other component and add all the critical pressure of that component, which becomes the critical pressure of dry air. The eccentric factor of each component we know, just multiply the mole fraction, it becomes eccentric factor of that component, and do the same exercise for other component and add all of them, becomes the eccentric factor of dry air. So in summary, critical temperature of dry air is 132.44 degree Kelvin, you can see here. Critical pressure of dry air is 37.064 bar absolute, you can see here, and eccentric factor of dry air is 0.03566, you can see here. The compressibility factor of dry air. Compressibility factor depends on temperature and pressure of air. So what are the data needed? Temperature and pressure are given, and critical temperature, critical pressure and eccentric factor of dry air you know how to calculate in the previous slide. So all these information is available, then calculation can be done. Pseudo reduced temperature Tr is equal to T upon Tc. Pseudo reduced pressure Pr is equal to P upon Pc. Factor K is equal to 0.374644 plus 1.54226 into small w minus 0.26992 into small w square, where w is the eccentric factor of dry air. Factor small e is equal to bracket start 1 plus k into bracket start 1 minus square root of tr bracket close whole bracket close to the power 2. Factor a is equal to 0.45724 into small e into pr upon tr square. Factor b is equal to 0.0778 into pr upon tr. Factor c is equal to 1 minus b. Factor d is equal to a minus 2 into b minus 3 into b square. Factor E is equal to A into B minus B square minus B cube. So once factor A, B is known, factor C, D, E can be calculated. Peng-Robinson PR equation, Fz is equal to Zq minus C into Z square plus D into Z minus D. After differentiation, we can write F dash Z, which is 3 into Z square minus 2 into C into Z plus D, where factor C, factor D and factor E are calculated based on air properties and operating temperature and pressure. First trial, put Z iteration method you have to use. So put Z is 1, then Fz is calculated because Z is 1, C, D, E is constant factor, we know that. So Fz is calculated, then next it F dash Z is calculated because Z is known, C is known, D is known. Then Z dash is equal to Z minus Fz upon F dash Z. Then error is Z minus Z dash. Next trial, now put Z is equal to Z dash. So now Z is replaced by Z dash. C and D is known. So Fz is calculated. Similarly, F dash Z is calculated. Then Z dash is calculated. Again error, Z minus Z dash. This minus this is calculated. So proceed with the further trial and stop when error is 0. Compressibility factor is equal to Z dash when error is 0. Calculate the compressibility factor of dry air at pressure of 1.013 bar absolute and temperature is 30 degrees Celsius. So now temperature in degree Kelvin 303.15, pressure is 1.013, TC/PCW, that is critical temperature, critical pressure, eccentric factor. With the previous slide you can transfer here. 132.44 is degree Kelvin, 37.064 bar absolute, and W is eccentric factor 0.03566. Now we can calculate TR, PR, factor K, small e, factor A, factor B, factor C, factor D and factor E. So once all factor is calculated, you can use iteration method. Z is 1, then Fz is calculated, then F dash Z is calculated, then Z dash is calculated and error is calculated. In the next trial, now F Z dash is transferred here, that is 0.999. Same calculation is done. Now error is 0, so this is answer 0.999. We have done more calculation, but result will be same. So same thing is transferred here. So compressibility factor is 0.999, constant. Moist air properties, dry air properties. Critical temperature of dry air, we can write TC1, which is 132.44 degree Kelvin. Critical pressure of dry air is PC1, which is 37.064 bar absolute. And eccentric factor of dry air is W1, which is 0.03566. Water vapor properties, critical temperature water vapor is TC2, which is 647.7 degree Kelvin. Critical pressure water vapor PC2 217.6 bar absolute, and eccentric factor of water vapor W2 is 0.344 constant. So moist air properties, critical temperature moist air Tc is equal to Tc1 into N1 plus Tc2 into N2. Critical pressure of moist air Pc1 into N1 plus Pc2 into N2. Eccentric factor of moist air W1 into N1 plus W2 into N2, where N1 is a mole fraction of dry air and N2 is a mole fraction of water vapor. Atmospheric air is having pressure of 1.013 bar absolute and temperature is 30 degrees Celsius and relative humidity is 70%. It is compressed in compressor and discharge pressure becomes 2.5 bar absolute and temperature of 120 degrees Celsius. Calculate the compressibility factor of moisture at inlet and outlet of compressor. Solution. First step, calculate the moisture properties based on the inlet condition. Also, it is understood that while compression pressure and temperature have increased and there is no condensation, so gas properties like critical temperature, critical pressure and eccentric factor will remain same as inlet and outlet. So pressure is 101.3 because in kilopascal absolute, temperature is 30 degree, relative humidity is 70. So saturated vapor pressure is calculated, then vapor pressure is calculated, then mass of water vapor per kg dry is calculated, then number of moles of dry air is calculated, number of moles of water vapor is calculated, then mole fraction of dry air is calculated, then mole fraction of water vapor is calculated. Once n capital N1, N2 are known, then critical temperature dry is given Tc1, critical temperature water vapor Tc2 is given, critical pressure of dry is Pc1 is given, critical pressure of water vapor is also given, and eccentric factor of dry air W1 is given, eccentric factor of water vapor W2 is given. Once all these information available, critical temperature of moist air is Tc1 into N1 plus Tc2 into N2, so it is coming 147.552 degree Kelvin. Critical temperature wrongly written, it should be pressure. Critical pressure of moist air Pc is Pc1 into N1 plus Pc2 into N2, which is coming 42.357 bar absolute. Eccentric factor of moist air W1 into N1 plus W2 into N2, which is coming 0.0447. So now moisture properties Tc, Pc, W is known. Same data is transferred here Tc, Pc, W. Next step, calculate the inlet compressibility factor based on inlet temperature and pressure and moisture. So inlet temperature is 303.15 degree Kelvin, pressure is 1.013, and these property of dry moisture is known. So we can calculate pseudo reduced temperature Tr, pseudo reduced pressure Pr, factor K, factor E, factor A, factor B, factor C, factor D, factor E. Once factor CD is known, iteration method can be used. Putting Z is 1, then Fz is calculated, F dash Z is calculated, Z dash is calculated, and error is calculated. Once this is done, then transfer Z dash here and then do the same calculation, and error is 0. So we have to stop 0.999. So step 3, calculate the outlet compressibility factor based on the outlet temperature and pressure and moisture properties. Outlet temperature is 393.15, pressure is 2.5 absolute. Tc, Pc and W is the same in the previous. Then we have to calculate pseudo reduced temperature Tr, pseudo reduced pressure Pr, factor K, factor E, factor A, factor B, factor C, factor D, factor E. Once factor CD is known, then again you have to calculate, put Z is 1, then Fz you have to calculate, F dash Z you have to calculate, then Z dash is calculated, then error you have to calculate. So since error is 0, this is the data, but you have calculated more calculation, but all are the same. So outlet compressibility factor is 1. So thank you. With this I have finished my lecture. Hope you like this. If it is so, please subscribe my channel, like it and share it so that you will get the intimation of new videos. See you in the next discussion. Till then, bye bye. Thank you.